Hello, my name is Christopher Demirs Jimenez, and this is my final presentation for CS 6795. My project follows the computational model track and provides a psycholinguistic framework to investigate whether frontier multimodal AI models exhibit global precedence. So, what is global precedence? On this slide, you can see an example of compound shapes composed of the letters H and S. Global precedence is the name given by Navon 1977 for the well-established phenomenon in which human subjects tend to recognize the overall global structure of a stimulus before identifying its local details. This makes global precedence a foundational concept in visual and cognitive science, demonstrating that the brain prioritizes holistic structure. Following from psycholinguistics, we may thus ask a research question relevant both to cognitive science and machine learning. To what extent do AI models exhibit human-like global precedence effects when confronted with hierarchical images designed with basic letter forms? Understanding this phenomenon is important because visual processing plays a role in everything from object recognition to reading, and it serves as a window into how the mind organizes complex information. As multimodal AI systems begin to perform tasks resembling human visual interpretation, it becomes crucial to ask whether they exhibit these same perceptual tendencies. To test AI models, I designed a Python-based workflow that generated global, local letter shape stimuli, and then prompted four different multimodal AI systems as listed on the screen, and then performed statistical analysis of their responses. In total, I generated 676 pairwise letter shapes, which is 26 global letters times 26 possible local letters, and then generated 2,704 API calls to OpenAI's models. I've listed the release dates here because it will become relevant when discussing results in the next section. To generate the global letter shapes, I used Donald Knuth's Font 36 from the Art of Computer Programming. Among other reasons, the main benefit of using Font 36 as a template is that it has several dimensions of regularity. Each character is composed of 36 subunits, and every character can be dissected into smaller pieces. Lastly, I'll mention that the prompt I used for the automated API calls was carefully crafted to match the original Navon studies from 1977 and 1981. Note that the prompt is not, "What symbols do you see?" but rather, "What is the first symbol you see?" Given enough time, both human and AI subjects can recognize multiple symbols in a given image. However, what global precedence means is what symbol is processed first. The results are actually quite fascinating. Overall, from the earliest model in GPT-4o to the latest model in GPT-5.1, we see a dramatic shift from local to global precedence. Whereas 4o identifies local letters first about 91% of the time, local precedence drops to 49% for GPT-5.1. Similarly, whereas 4o exhibits global precedence only 8% of the time, GPT 5.1 reached 32% of global precedence only a year later. This slide shows four heat maps comparing the local precedence of each model per individual letter. Yellow squares represent high proportion of matches between the true local letter of a given stimulus and the first symbol perceived by each model. As the heat maps show, the frequency of local precedence decreases from 4.0 to 5.1. Additionally, we observe some per letter variation, with certain letters resulting in higher global bias, while others cause processing errors. Conversely, this slide shows four heat maps comparing the global precedence across the AI models, showing that newer models are beginning to exhibit more and more of it. 4.0 shows almost none, while GPT-5 Mini and GPT-5.1 show visible diagonals, indicating stronger global precedence at a rate of near 100% for certain letters, such as the letter T. This project shows that multimodal AI models are beginning to exhibit global precedence effects that increasingly resemble those found in human perceptual research. Although early models remain dominated by local detail processing, newer architectures display a measurable shift towards global first behavior. These results demonstrate that psycholinguistic frameworks can meaningfully illuminate how AI systems interpret visual information, thus offering a bridge between the theories of cognitive science and the behavior of modern machine learning models. Finally, this project could be extended in a number of directions. I've included three possibilities on this slide, including adding different fonts and testing different models outside of the OpenAI ecosystem, but the most important extension, in my view, is the one listed first, which is to incorporate non-Latin writing systems to test global precedence across languages. This has been done for humans and would be worthwhile to test for AI models as well. Very quickly, here are my references, and here is my research poster. Thank you very much for watching.